Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to all judges. My name is Wan Muhammad Syakirin bin Wan Muhammad Badru Hisham.
And I am Nur Ismahani binti Aziz.
My name is Umayya Kidono Arabia, the advisor of this team.
First of all, by looking at today's issue, according to the UN Environment Programme, the Earth's temperature will rise at 2 degrees Celsius above pre-industrial level approaching 2050. This is caused by the enormous emissions of carbon dioxide and also the greenhouse gases, especially from the conventional electric power plant that has emitted in about 1.55 billion metric tons of carbon dioxide every year.
Regarding this situation, we present to you a smart system that is integrated with nuclear energy and IoT called I-Ness.
So, we align our invention today through two sustainable development goals, which are SDG 7 that focus on clean and affordable energy by the use of nuclear as the main electrical source, and the second one is SDG 12, which focus on sustainable consumption and production by the 7 usage of electricity in our daily life.
So, to integrate nuclear energy in smart I-Ness, we implement nuclear energy as the main source of electricity. Justification: according to American Geoscience Organization, nuclear power plant can produce 1 gigawatt of electrical power without causing any air pollution, while a fossil fuel power plant can only produces 1.6 thousand megawatt of electrical power, but also it releases air pollutants such as carbon dioxide.
Now, let's look what are the main purposes of our invention. First, it is to ensure the sustainable consumption of electricity in our daily life, to implement the smart city in society, and also to monitor the electrical appliances according to the surrounding environment. Now, let's talk about the system. The main source of energy that we do apply in our smart I-Ness system is nuclear power supply that supply 240 volt of power energy, and it will be transferred to the MCB, which is also known as miniature circuit breaker that protects the circuits from any abnormal condition. The energy power in MCB will be transferred to the relay, and it thus works as an automatic switch to control the high current using low current signal, which is from 240 volt to 5 volt.
Let's move to the microcontroller. In smart I-Ness, we are using ESP32 microcontroller that can be connected to the Wi-Fi so that we can emphasize IoT application in our smartphone. So next, let's focus to the input that we have implemented in smart I-Ness, which are LDR sensor, DHT11 sensor, and also IR sensor. The first one is the DHT11 sensor, which is used to detect the air humidity and also surrounding temperature. This sensor will be synchronized with the LCD I2C, the IoT application in our smartphone for the monitoring purposes, and also the fan for the automatic switches. The LDR sensor is used to detect the photosensitive brightness resistant. In this system, the LED will be only turned on when there's dark and also there's human passing through this sensor. Infrared sensor is used to detect any appearance of human. So in smart I-Ness system, we are using IR sensor to detect any appearance of human for the automatic switches of the LED. Sir, can you ever imagine if you are the busiest person on this planet, but you are still using the conventional control system, I mean like by your own hand? Such a waste of your time.
Judges, no problem. In our invention, we do provide two ways to control the system, which is the first one is through automatically detected by the object sensors, and the second one is through Arduino IoT remote that can easily be controlled in our smartphone.
Next, let's focus on the output that we have applied in smart I-Ness. The first one is the LCD I2C, which is a display set that is used to display the value of surrounding temperature and also air humidity that is recorded by the DHT11 sensor. The second one is the bulb. These bulbs are connected with the infrared sensor. Example, whenever a human are passing through the IR sensor, this bulb will be automatically turned on. And same goes when the human are getting away from the IR sensor, this bulb will be automatically turned off.
Next, we do have fan that acts as an element to cool down the surrounding temperature, and it can be easily be controlled through Arduino IoT remote in our smartphone. For example, before you go home from work, if you notice that your house temperature is hot, then you can just turn on the switch of the fan through Arduino IoT remote easily. And same goes, when you notice that your house temperature is already drops, then you can just turn off the switch of the fan through Arduino IoT apps in your smartphone. On the other hand, we do have socket outlets which also can be controlled through Arduino IoT remote, and it is able to be used for any electrical appliances charging such as air conditioner and etc. So, end of explaining the overall function. Now, let's look. The overall cost of our construction of Smart I-Ness system is worth RM236.50. Last but not least, judges, can you ever imagine what are the benefits that we would gain by these applications of Smart I-Ness system? First, we can save more energy by the use of automatic switch control in our electrical appliances. Second, we can save more electrical bills, and also, the last one is, it can ease our work to control the electrical appliances by only through Arduino IoT remote in our smartphone.
In conclusion, Smart I-Ness can save more energy, money and nature. Thank you for lending your ears. Assalamualaikum.